Hello everyone, welcome to a mathematics session. Today I am continuing with the transportation problem. This is a transportation problem. This is a transportation problem. In my previous, this is lecture 2. In my lecture 1, I have taught what is the meaning of a transportation problem and what are the essential definitions of a transportation problem, how to find the initial basic feasible solution. This is called initial basic feasible solution. So this is IBFS. How to find the initial basic feasible solution using VAM. VAM means Vogel's approximation method. Vogel's approximation method. I have taught the method of finding the initial basic feasible solution, by which I mean finding the allocations, finding that allocation for which the overall cost of transportation is minimum. This is the aim of this transportation problem. That means you have got sources which are nothing but manufacturing units, and the sales outlets are there, which are called the destinations. You send the product to the destinations, different destinations, for which you require transport. You have to spend on transport. Now the question is, how much, that is, how well are you going to utilize the transport services to send the materials to the destinations, so that the overall transportation cost is kept minimum. And that two things that you must know, that is, before prior knowledge which are required to be known in the transportation problem are: number one, you must know how much each source is capable of manufacturing. How much each source is capable of manufacturing, and what are the requirements of the destinations. Are you able to understand? The two things. What is the first thing? How much capacity each source has, that must be known, and how much requirements are there for every destination. The availability and requirements must be known. Availability means the number of units the sources manufacture, that is called your availability, and requirement or the demand of the destinations. This must be known in advance. Second thing is the unit cost of transportation from one source to another, to source to a destination, must be known in advance. That is, the cost of transporting one unit of the product from the source to a particular destination must be known in advance. These two are the prior requirements. Only then you can do the problem. The rest of the things I have explained everything in my lecture 1. Go through the video class. You will find everything very understandable. If you have any doubts, you can write to me. You can write your comments. Now, here you see that this is, as I told you, this is not the optimal solution, in the sense that you see that what is the solution of this. Now The solutions are nothing but, here you see that, what is the meaning of solution? The solution means the allocations. Now you see that here this allocation is x11. See, I'll write here x11 is an allocation into its C11. That is the cost. X11, this is what I should find, and it's then. You see that x12, this is the solution, multiplied by C12 plus. So here you see that x22 is a solution and the cost is C22 plus x23 is a solution multiplied by C23 plus, come to this, x33, see, 1, 2, 3, x33 is a solution, this is a solution, this is a solution, into C33, C33, then x34 into C34 plus x41 into C41. If you find that, this will be equal to your 1010. Just see whether this is correct. So you see that what is the meaning of solution? Solution is nothing but finding the allocations using either northwest corner method or least cost method or Vogel's approximation method. I have used Vogel's approximation method because it gives the least, it gives the better allocation to reduce the cost. It gives a better allocations. Now, so compared to northwest corner method and least cost method, therefore I use that method, I am able to get x11, x12, x22, x23, x33, then x33, x34 and x41. If you multiply this, see what is your x11? 65 into 6. So this is what you will get. See, it is like this, 65 into 6 plus 5 into 1 plus 30 into 5 plus it is 25 into 2 plus 25 into 4 plus 45 into 7 plus 20 into 0. This, if you just see that whether this is what you get. So you see that I am getting this. Now I cannot stop with this. Our mind will always try to probe into things and find out whether it is still reducible, or able to understand whether it can be brought lower than 1010 rupees. Whether, see, don't think that 1010 rupees means 1010. It is 1010 units of rupees. In very big companies, you see that it may run to even crores. It may. So in where if you are going to reduce even by 1 rupee, you see that you will gain a lot. So that is why you cannot think it in the line of only 1010 rupees. It is not like that. It may be units of rupees. Can you understand? So our mind, the officials, that is the people who are in the accounts department, they will try to see that by doing other methods, by using by doing some manipulations or doing some different type of allocations, whether the overall cost can be still brought down. So this is the work of the people who are in the account side. So this is what is, for which only this operation research helps you. So you see that now let us use, there is one method called MODI method or modified distribution method, which helps you to find out a better solution. I tell you that this can itself be a better solution, but I will use that method and confirm that whether this can be retained or whether there is a chance that we can bring less than 1010. Can you catch what I am telling you? So I will do that. Straight away I will start doing this problem, because those who are really viewing this should have some background of this transportation problem, and that you will be able to understand each and every terminology that I am using in the class. Okay, with this small introduction, let me start completing the problem. Now you see that, the method of doing I am telling you, there is a big, and you try to understand that it is also a simplex method. We have taught you a simplex method. You go through my videos. I have put some 2 or 3 or 4 videos on simplex methods. You go through them, you will find each and every step will be explained. So this is also a linear programming problem only, but the thing is that here the treatment is slightly different, because we cannot give the same treatment as we have given for a linear programming problem, like that is we have given, okay, in the problems. Now here it is different, that I am going to give a different, I am going to tackle it in a different way, and this method is called MODI method. MODI method means what? Modified MODI method. It is a MODI method, that is modified distribution. So this is a modified distribution method or MODI method. Here what you should understand is, see, here you have given some allocations. My question is, see, you find here this 225. Naturally here you can find that 425. See, your mind will naturally go in a way that why not we send from this source to the destination force, so that the cost is minimum. Can you understand? So you see that what is this 3? 3 is nothing but the unit cost of transportation from the source 1. See, it is the source S1 to D4. So your mind can tell you whether is it not wise to send materials from S1 to D4, because the unit transportation cost is 3. So this is it's actually correct thinking like that, but I am concentrating only on overall reduction in the minimization of the cost. I cannot just check only this and do the problem. I must think overall what the overall reduction of the transportation cost, minimization of the transportation cost. So you may ask such questions, but that is not the way we approach it mathematically and find out how it should be done. Okay, for which only we are using what is called. So you see that here, but your thinking is correct in the sense that why not we do some different distributions. What is that? Different distributions. Why not we shift from here to this, or why not we shift from somewhere? You do some shifting of the allocations so that it is possible to get minimize the still further. Can you understand? So that is what I am trying to do, and it is as good as finding the non-basic solution in a simplex method. So this is what is happening, but about which you need not go deep into that. Just understand the way how this problem is done. Okay, now you see that, call this as U1, call this as U2, call this as U3, call this as U4. Likewise V1, V2, V3, V4. So call like this. Then see, I with the assumption that you know something about transportation problem and you can follow whatever I am going to say connected with the problem, I am explaining things. If you have prior knowledge, it will be very good. Okay, otherwise you just follow very carefully what I say and just go through a book, you will find it easy. Okay, now let us start doing this. See, how do you do this? So you take this, so you name the rows as U1, U2, U3, U4. How many number of rows are there? You name them in the way. And likewise the columns. Then what is the next step that you must do is, so your first step is name the rows as u1, u2, u3, u4 like that, and columns are v1, v2, v3 like this. Then see, you choose any of the rows or columns which has the maximum number of allocations and assign value 0 to that variable. See, here you see that there are 2 allocations, here also 2 allocations, here also 2 allocations, here there is only 1 allocation. In this column only 2 allocations, here there are 2 allocations, here there are 2 allocations, here there is only 1 allocation. So but you have to assign 0 to any one of the variables u1, u2, u3, u4 or v1, v2, v3 up to v4 which has the maximum number of allocation. Since you find the maximum number to be this, I will take this u1 is equal to 0. Take u1 is equal to 0. Then use the formula that, it is a formula like, it is, you take it as a formula, ui, see, you take like this, ui plus vj is equal to cij. So what is that? Use this formula in the sense that u1 plus v1 must be equal to your 6. Can you concentrate only on the allocated, that is, you have to, what I mean is, you have to find all the values of the variables. What is that? You have to find the values of all the variables here by fixing one of the variables as 0. Can you catch what I am telling you? So find out the values of all the variable, fixing one of the variables as 0 which has got the maximum number of allocations. Here in this particular case, you have got maximum to be 2. So without loss of generality, I have taken this to be 0. Now use this formula ui plus vj is equal to cij to get the all other variables. For example, you have taken this. So what is it you will have? u1 plus v1 is equal to c11. Say u1 plus v1 is equal to your 6 and take only allocated cells. Take only allocated cells. So you take only the allocated cells and do this operation. In this, perform this. That is u1 plus v1 is equal to c11. That means what? 0 plus v1 is equal to 6 means v1 is equal to 6. Am I correct or not? Say u1 0 plus v1 is equal to 6 means v1 is equal to 6. So u1, see, 0 plus v1 is equal to 6 implies v1 is equal to 6. So I am able to get this as 6. Now you see that when this is 6, I will write only 1 now. See, what is that you will have? u4 plus v1 is equal to 0. Can you see this? u4 plus v1 is equal to 6, 0. u1. Now, what is the value of u1 you have got? 6. So, u4 plus 6 is equal to 0. So, u4 is equal to minus 6. So, what is the value of this? It is equal to minus 6. Can you catch this? And likewise, this is, see, this is an allocation. This is an allocation. I'll write it close to that so that you will understand. So, you see that 0 plus v2 is equal to 1. Therefore, v2 is equal to 1. Can you understand? Now, you come to this. u2 plus v2 is equal to 5. See, I'll write here u2 plus v2 is equal to u2 plus v2 is equal to 5. But what is your v2? 1. So, u2 plus 1 is equal to 5. So, u2 is equal to 4. So, what is this? u2 is equal to 4. Likewise, you see that u2 plus v3 is equal to 2 means this is 4 means this is equal to minus 2. So, 4 minus 2 is 2. And come to this, what else can you find in this? Now, see, I want this, see here, this one we can find, this is minus 2, and here you see that u3 plus v3 is equal to 4 means how much will you have? This is equal to 6 minus 2 is equal to 4. Then you see that this V is equal to 1, 6 plus 1 is equal to 7. So you see that I use the formula Ui plus Vj is equal to Cij is equal to Ci. Ui plus Vj is equal to Cij. So what is that you must understand is, you write name the rows and columns as U1, U2, U3, Un, and V1, V2, V3 up to Vn, like that, and then assign the value 0 to any one of the variables which has the maximum number of allocations, and then use the formula Ui plus Vj is equal to Cij to get the values of all the variables. Okay, so this part is over. Now then what is that you must do here is, then come to the unallocated cells. So that is using come to unallocated cells. Now come to unallocated cells. Now what is that unallocated cell? Now use the formula. So you write this, you find Ui plus Vj. Come to the unallocated cells and find Ui plus Vj. See, come to this. Let me come to this. Here with respect to this is 0 and the column is this. So 0 minus 2 is minus 2. And come to this. See what is that you are having here? 0 plus 1 is 1. Come to this. 4 plus 6 is 10. Then come to this. What is that you'll have here now? So here you'll have, don't take this is allocated. Don't take this is allocated. Come to this. 4 plus 1 is 5. Come to this. 6 plus 6 is 12. Then 6 plus 1 is 7. Don't take this allocated. Don't take this allocated. Don't take this allocated. This is minus 6 plus 1 is minus 5. Then minus 6 minus 2 is minus 8. Minus 6 plus 1 is minus 5. Then find Dij, which is equal to, see, it is Ui plus Vj minus Cij. See what is that you will do now here? See, it is like this. So you see that here Ui plus Vj. See, you want this. You find I coin Dij. This Dij you take it as Ui plus Vj. What is that you want here now? See, for example, you have got here Ui. See here Dij. See, you will have it as, see, Cij I know. What is that? Here I will write this. I will write this step very clearly, then only you will understand. See this one. See Dij. This Dij, here it is Dij. This is, yeah, this one. Now you see that this Dij, here this is Dij. This Dij is nothing but what? Your D13. Says D13. The D13 is equal to U1 plus V3 minus C13. Now U1 plus V3 you have found. It is minus 2 and it is minus 9, which is equal to minus 11. It is minus, see, it is Ui plus Vj. It is minus 2 U. This one is just write like this. It is a formula. It is a formula. It is minus 2 and it is minus 2 you will add here d13 will be 11. So this is, you must get it as 11 is equal to, I will tell you how you should get, I will write that. So you will get this to be this one Cij, it is like this, I will write here. The formula is like this. It is Cij is equal to Ui plus Vj minus Dij. This implies Dij is equal to Ui plus Vj minus Cij. So your Dij must be equal to, it is this is 9. So this is Dij. If I want this one, I will write it here. Dij, d, what should be added with this? D13 plus U1 plus V3 is equal to C13, or D13 is equal to C13 minus U1 plus V3, or Dij is equal to Cij minus Ui plus Vj. So this is a formula, like I am not, this is a it's a method of doing it, and we have to find one factor called Dij. This is called Dij. We have to find one Dij factor which is equal to Cij minus Ui plus Vj. This is a formula, like you can take this as a formula. For example, how do you do this? I want this D13. D13 is equal to C13 minus U1 plus V3. C13 is what? 9. Minus U1 plus V3 is minus 2, that is equal to 11. So what is your D13? D13, this is your 11. So you can ask one question. What will you add with this minus 2 so that you will get 9? You can ask that question also, so that you will get the answer. Here minus 2 is there. What will you add with this minus 2 so that you will get 9? So you have to add this 11. So that is your D13. The next one I will do. Now what is your D14 now? What is your D14? It is equal to C14 minus U1 plus V4. Now what is that? It is U14, C14 is 3 minus, what is your U1 plus V4? It is 1, that is equal to 4. So this is, it is D14 is equal to C14 minus 1, that is equal to 2. So you see that I have got this to be 2. So you see that what is the question that you will ask? What will you add with this 1 so that you will get 3? So 2. Now similarly answer this question. See, you have got 10 here. What will you add at the bottom so that you will get 11? So this is your D21. Don't take this, don't take this, come to this. What will you add with this 5 in order to get 8? It is 3. So this is your D1, D24. Come to this. What will you add with this 12 so that you will get 10? It is minus 2. It is minus 2. So your Dij, note this. This is Dij. D13 is equal to minus 2. D13 is minus 2. So how do you get this? So you ask this question because the same formula is the same. Formula remains the same. Don't change the formula. But I am telling you the easiest way to find. You ask the question, 12 is here. What will you add with 12 in order to get 10 means it is minus 2. And here let me come to this. So this is what you have here. See, 12. Now I am asking you the question. 7 is here. What will you add to get 12 here? 5. Don't take this, come to this. Now, what will you add this minus 5 to get 0? 5. What will you add to this minus 8 to get 0? 8. What will you add? So curious that. Now, you see that in all places you have got Dij to be, say this is positive, 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 and this is positive, whereas this is only negative. So when it negative comes, you must stand it. Suppose if you get minus 2 and somewhere minus 3, you must take the maximum negative as in the simplex method. Can you understand? Suppose you get minus 2 and here you get minus 3 means you have to concentrate on this cell and not on this. But luckily we have got a negative Dij coming only in the CD13. See, that is the third one. See, it is 3-1. I am sorry. This is 3-1. D31 is equal to minus 2. Third row, first column. Third. D13 is equal to minus 2. I am sorry. So D13, this is D13 is minus 2. That is third row, first column. You get the D value to be negative. That means, I will tell you in my own language that if such a cell comes, negative Dij comes, it is as good as that cell is asking you to reallocation, do some reallocation and allocate to me certain amount so that the overall cost is likely to come down. Are you able to catch what I am telling you? So if you get a negative Dij in any one of the cells, it directly tells you why not you go for reallocation and allocate to my cell so that there is a possibility for the overall cost to come down. So this is the meaning. And another point that you must know is, if you have two cells having negative Dijs, then you have to choose that cell which has the maximum negative. Suppose if it is minus 2, minus 3 means what? Choose the negative minus 3 cell for your reallocation. Are you able to understand? Now let us start doing this. So this is all about this, how to find this Dij. So having found this, the Dij is mainly found, it is as good as simplex method. The Dij factor is mainly found in order to find out whether if reallocation is done, to which cell the allocation must be done, to which cell the allocation can be done so that the overall cost can come down. So that is the purpose of finding the Dij. For finding the Dij, you have to find, first of all, you must find u variable and v variable, fix the 0 for any one of the variables, and then find the values of all other variables using ui plus vj is equal to cij. Then go to, using the allocated cells, then go to the unallocated cells, find ui plus vj for every all allocated cells. Then you find Dij using this formula. You will find that if you get all positive, let us suppose that this is also positive, means the solution that you have got presently is the maximum. What is that? Suppose if you happen to get this also positive, means it means that the present solution that you have got using the Vogel's approximation method itself is the minimum. That is the minimum possible. Further lowering the cost is not at all possible. So you can stop the problem. But if you get a negative anywhere, it means Dij negative, it means that try to go for a reallocation and allocate to that cell and so that there is a possibility of the overall cost coming down. So that is the meaning of that. So if this is also positive, don't stop it, because there is no Dij negative. Your problem is solved. Okay, now we have got this. So I am going further in order to for a reallocation, and my allocation will be on this cell. Concentrate on this cell. Now what I will do here is that, here you see that I will write this. So what is that you must do is, see, write everything here. 6 1 9 3, and it is 65 5, and then 11 5. I am rewriting 11 5 2 8, and then 10 12 4 7, then 0 0 0 0. It is 665 665 1 5 9 3, 11 1 11, no, 530, then 225, then 7 4 25, 745 0 20. See, it is not a problem of degeneration in the sense the number of solutions must be m plus n minus 1. Number of rows plus number of columns minus 1. So your maximum solution can be only, here it is, see that number of 4 rows and 4 columns. 4 plus 4 is 8. 8 minus 1 is 7. So maximum number of solutions can be 7. If it is less than 7, it is called a problem of degeneration. Then it has to be tackled in a different way. I will take a problem on that afterwards. Now you see that 665, write properly without mistake, then otherwise you will get it wrongly. Then 11 530 245 8 10, then it is 12 425 745 0 20 and everything. Now let me rub off this. Now what is that? Which cell is now you have to concentrate? So you have to concentrate on this cell. So call it as plus theta. Plus theta in the sense that you have to necessarily allocate something for that. Okay, you are going to allocate for that, and remember that while you do the reallocation, your rim condition should not be violated. You know what is the meaning of rim condition? Rim condition means the sum of the allocations in a row is equal to the availability in that row. The sum of the demands in any column is equal to requirement at that destination, in the sense that, see, 65 plus 5 is 70. So your rim condition is satisfied. 65 plus 20 is 85. Rim condition is satisfied. This must be true for all rows and columns. Okay. So if you go for reallocation also, your reallocation must be done in such a way that the rim condition is not violated. Now let us start doing this. Now you see that here I am going to do this. So what is that you must do is, now you have to draw horizontal and vertical lines, and from the plus theta cell, and come back to it. So that, yes, it may be a square or a rectangle or any other geometrical formation can be that. See, for example, you see that from here you can go to this. You cannot go to this, because if you go to this, you must use vertical and horizontal lines. Connect through vertical and horizontal lines the allocated cells. So you see that you come to this, then you can come to this, then you can come to this, then you can come to this, you can come to this, then you can come. You can bypass the allocated cell also. While you draw the vertical and horizontal lines, you can bypass the allocated cells also. Nothing wrong in that, but you must know that you are able to connect using vertical and horizontal lines these cells. See here, immediately from here to here, then from here to here, then here, then. So you see that I am able to get some geometrical figure with horizontal and vertical lines connecting the what? The allocated cells. Then after that you start alternately, you give plus theta, minus theta, like that. So you see that this is your minus theta, this is your plus theta, this is your minus theta, this is your plus theta, this is your minus theta. So you see that I am connecting it by what? This is plus theta, minus theta, plus theta, minus theta, plus theta, minus theta. Then choose, see, minimum of min of minus theta cells, that is equal to minus theta cell allocations. Minus theta cell allocations. Now what is that minus theta cell allocations? Here it is 25. Here it is 5. Here it is 65. So it is equal to 5. Add this 5 to plus theta cell allocation and subtract from minus theta cell allocation. Minus theta cell allocation. That means what? This is your 5 plus theta cell allocation, add 5, subtract 5, add 5, subtract 5, add 5, subtract 5. Can you understand? So I'll repeat this. You, after drawing this, that is connecting this plus theta cell with other connected other allocated cells using vertical and horizontal lines, you come back to the play. You must form a loop. You must form a loop. Then write alternately minus theta plus theta, minus theta plus theta, minus theta, like that. Choose the minimum of the minus theta cell allocations. Add that particular allocation with the plus theta cell allocation and subtract it from minus theta cell allocation. So this is what now what is that I will get here. Now I hope that those who are watching this video will be able to tell what I am doing here. So 6. Here you subtract this. So it is 6 means subtract this 5. It is 60. It is okay. It is this one I'll call this. Here it is. See, minimum of here 25 allocation, it is 30 allocation and 65. So this is equal to 25. So add this 25. So add this 25 with plus theta cell and subtract it from minus theta cell. I am sorry, because this is, see, this is allocation. This is allocation, minus theta cell allocation, this is minus. So this 25, this is the 30 allocation. 25 allocation, 30 allocation, 65. Minimum is 25. Add with plus theta cell and subtract it from minus theta cell. So what is that you will get here? 60. 65 minus 25 is 40. Then 1. You have got here 65. This is a plus theta cell. So add that 25. It is 30. All other things will remain the same. Then it is 11. Then you see that this is a minus theta cell. You have to subtract 25. So it is 5. Then come to this, it is plus theta, so you have to add this 25, it is 50. So it is 250. Then you see that it is 80. Then 10, this plus theta cell, you have to add this 25. Then it is 12. Then 4, you have to subtract this 25. So 0, don't write 0. Then 745. Then it is 0. It is not disturbed. 0, 0, 0. So this is what I have. Now you see that here I have gone for a reallocation. I told you that this was the minus theta cell, this was the plus theta cell, so for which I am now allocated 25 units. 25 units. But I told you that while you go for reallocation, the rim condition should not be violated. You see whether it is there. 40 plus 30 is what? 70. 5 plus 50 is what? 55. 25 plus 45 is 70. And here 20 is there. Vertically 40 plus 25 is 60. 60 plus 20 is 85. Then it is 30. 30 plus 5 is 35. You have got here. Then 50 is here. And then 45 is here. So rim conditions remain the same. I am not disturbed also. So you should not do that. Violation of rim conditions should not be there. So I have done. Now this is the solution that you have got. Now how to verify whether this solution is maximum or not? That means what? Least. Whether this, we have got a new different solution, whether this solution can be taken, because there is a change taking place. Here there was 5 and we have made what? This is increased, this is decreased, like that some changes have taken place. Whether this change has resulted in lowering the cost, we have to verify. For which again you have to perform, you have to again, say this may give you less, whatever it is, this may give you less, but whatever it is, you have to verify whether this is a lesser solution, for which this Modi method must be applied. U1, U2, U3, U4, V1, V2, V3, V4. So you see that now let us take this to be 0. You can take, see, you can take this to be what? 0. You can take this to be 0. If you take this V1 is equal to 0, U1 plus 0 is equal to 6. So this is your 6. Then V1, U3 plus V1 is equal to 10. So this is equal to your 10. U4 plus V1 is equal to 0. So this is also equal to 0. Using the formula Ui plus Vj. Ui plus Vj is equal to Cij. Okay. Now having got this, now let us come one by one. See here you have got here. See here you have got. This is 10. U3 plus V4 is equal to 7. So this is minus 3. Can you get here? 10 minus 3 is 7. Okay. Then what else can you find here? Then see here you can. This is 6. This is an allocated cell. This is an allocated cell. This is an allocated cell. So 6 plus V2 is equal to 1. So V2 is equal to what? Minus 5. 6 minus 5 is equal to 1. Okay. Then here minus 5 is here. This is an allocated cell. So this will be equal to your 10. 10 minus 5 is equal to 5. Then here you have got 10 here. Here you want 2. So this is equal to your minus 8. So you see that this is the maximum number of allocations. So I have taken it to be 0. So for this U1 plus V1 is equal to 6 means here this is 0 means this is 6. For this U3 plus V1 is equal to 10 means this is 10. Likewise you fix this. Now come to unallocated cells. Add Ui plus Vj. See, come to this is unallocated. Minus 8 plus 6 is minus 2. Now I told you there itself we can find what is this Dij value. See what is this? This is very very important. This is your D13, very very important. So this is the deciding factor, D13. How do you get this? I have given you the formula. Go through the formula. I will not use that formula, but I will ask. My question is, minus 2 is here. How much will you add so that you will get here this 9? So this is 11. So 11 minus 2 is 9. So this is positive. So okay, I am fine with this. Then come to this. See, minus 3 plus 6 is plus 3. Now how will you fix this? How much will you add so that this plus, see this, and I'll mark it like this, this plus this must be equal to 3. So what will you write here? This is 0. So this is also positive. Whether 0 or positive, don't bother about that. Then come to the unallocated cells. 0 plus 10 is 10. How much will you add with this 10 to get 1? It is 1. So you see that this one, okay, positive quantity. Then come to this. 10 minus 3 is 7. How much will you add to get 8? 1. So this is also okay. I am fine. This is positive. Don't take this, come to this. Minus 5 plus 10 is 5. How much will you add with this 5 to get 12? 7. So this is also okay. Come to this. Minus 8 plus 10 is, it is 2. How much will you add with this 2 to get 4? It is 2. So this is also okay. Come to this. Minus 5. How much will you add to get 0? It is 5. Come to this. It is minus 8. How much will you add to get 0? 8. Then it is minus 3. How much will you add to it? So this is positive. This is positive. This is positive. Go to unallocated cells only. So this is positive and this is allocated. Don't worry. And this is positive. This is positive. See here. It is positive. So Dij's are greater than or equal to 0 for all I and j, in the sense that D11, see, D13 is positive, D14 is 0, D21 is positive, D24 is positive, D3 is positive. Okay, then you see that this one D41 is positive. Can you understand? So what are the solutions? So here all Dij's are. Therefore the solution is, here come to this, X11 C11. This is X12 C12. Come to this, no, this is X22 C22 plus X23 C23 plus, come to this, this is X31 C31 plus, come to this, X34 C34 plus X41 C41. So this is equal to, multiply this, 6 into 240 plus this is 30. Come to this for 25. Come to this 100. Come to this 250 plus, don't take this, this is 7 into 45 is, it is 280 plus 280 plus 35, it is 315 plus this is 0. So how much will you get here now? 0, 5, it is 5. See here it is, yes, see 0, it is, I will do this here, 240, then 30 plus 25 is 55, then this is 250, then 315, 10, it is 240 plus 55 plus 100 is there, plus 250, plus 100 plus 250 plus 350. Now you just see that it is 10, units of. So what is that? So you see that earlier we had 960 units of rupees, but earlier we had previously, what is that you had previously? Previous overall cost of transportation is equal to 1010. Now what is that you are having here? 960. So you see that, don't go. So this was your first one. If you use this, your expenditure will be 1010. But if you use this allocation, you see that you are 960. Therefore, it is better that you go for this allocation, so that your overall cost will be minimum. So this is all about this. We will see more problems in the coming days. Thank you.